first starting out with AWS, it can definitely seem overwhelming. This is true even if you have experience working as a developer or if you've already worked with some of the smaller cloud vendors like DigitalOcean and Linode. One of the reasons it's complex is due to the number of services AWS offers and its unique billing model. AWS is truly an on-demand, pay-per-use solution with what can seem like a never-ending list of customization options. Each AWS service also requires knowledge on navigating the interface and working across different regions. Keep in mind that AWS has data centers across the globe. Some AWS services are administered globally, whereas others are region-specific. This can add an additional layer of confusion when you're first starting out. That being said, by the end of this module, you'll easily be able to navigate the interface and make sense of the AWS services relevant to the AWS Cloud Practitioner exam. You will also have a foundational understanding of AWS billing and how to control your account to make sure it does not exceed customized budget thresholds. Furthermore, you'll be able to implement security practices to maintain the integrity of your account and prevent any unauthorized use. Before we register an account, it's important to understand the type of account we'll be registering and how you're billed for the services you use on AWS. Unlike other platforms, if you don't pay close attention to the resources you use, or if your account is compromised, you can easily be on the hook for a significant amount in usage fees. Without proper controls and security, there is really no ceiling to how much resource usage can accumulate under your account. And if that sounds scary, it's because it is. AWS offers its customers a level of freedom and control that is rarely seen even with its top competitors. However, with this added level of flexibility can come consequences. It's very important to thoroughly understand the best practices and billing methodology behind any service you use on AWS. Unfortunately, there's no shortage of horror stories from first-time users who hop on the platform and deploy services without fully understanding how they work. First, let's go over the basics of how AWS bills for the usage of its resources. We do have an entire section dedicated to AWS pricing, so for now, we'll just provide a high-level overview to get started. There are a few points to keep in mind as we progress through this lecture. AWS works on a pay-per-use pricing model. You pay for the resources you use on each billing cycle, which is typically monthly. To keep it simple, resources refer to things like storage, computational power, RAM, and outbound data transfer. You pay less by using more. AWS offers volume-based discounts as your usage of resources increases for specific services. For example, AWS S3 storage and data transfer out from an EC2 virtual server offers a tiered pricing model. Let's go over an illustration which will show the change in price per gigabyte of data stored on S3 as the usage increases. So we're here on the AWS pricing page, and they have an illustration to demonstrate the difference in pricing for S3 storage based on usage. On the left-hand side, you can see if you were to store up to 50 terabytes of storage, you'd be paying 0.023 cents per gigabyte per month. Now, if you use 51 to 100 terabytes of storage, the price drops to 0.022 cents per gigabyte per month. And on the right, if you use 500 terabytes or more of storage, the price drops even further to 0.021 cents per gigabyte per month. Another important consideration is that you save when you reserve. You can save up to 75% on costs when you commit to using a consistent amount of resources from AWS. This form of pricing entails a longer commitment, which can be structured in one of three ways: all upfront, partial upfront, or no upfront. Let's go over an example which will illustrate the price drop in usage fees for an EC2 virtual machine using the 3 reserved pricing models. So we're back on the AWS pricing page, and they have this illustration here. So on the left-hand side, if we were to reserve this specific instance, the EC2 M4.large instance, if we were to reserve it for a year but pay nothing upfront, we'd be paying $650 per year. If we were to use this instance on demand, so essentially we wouldn't be reserving it for any period of time, we'd be paying $955 per year. So the cost savings for reserving this instance for 1 year and committing to using this instance for 1 year is 32% savings. Now, moving towards the right. If we were to reserve this instance for 1 year and make a partial payment up front, we would be paying $554 per year for the instance. Compare that with $955 per year if we were to use it on demand. That would be a 42% savings. Now lastly, if we were to reserve this instance for 1 year and pay all of the cost of that instance up front, we'd only be paying $545 per year versus $955 on demand, which calculates to a 43% saving. So you can see the difference is quite substantial if you were to pay all up front versus on demand. Now, in case you're wondering, resources can be reserved for 1 or 3 year terms. As mentioned previously, of course, the billing method of AWS is a lot more complex than this. This is just to give you a high-level understanding of different ways the pricing models can work. We're going to be going over this in much more detail later on in this course. Seeing as how AWS can be overwhelming for new users just starting out, they've created what's known as the AWS free tier. Later in this section, we will provide a walkthrough of setting up an AWS free tier account so you can follow along as we guide you through the course. AWS free tier is perfect for those interested in learning how to use AWS without having to incur expense. It's perfect for developers looking to test small applications on a scalable cloud platform, and anyone new to AWS looking to take advantage of a great service while saving on usage fees for the first year. Once you sign up for the free tier, it's very important to ensure you do not exceed the usage guidelines specified under the plan. You will be billed for any usage that falls outside of the scope of the plan. For this reason, it's a good idea to set up billing alerts. We'll go through how to do that later in this section. You can find detailed information on free tier limits by visiting this page. This Amazon resource gives a listing of different services that are free to use under your AWS free tier plan. So on the left, you can specify the tier type. Below that, you have different product categories. And on the right, you have a listing of the services under the search criteria that you've narrowed. But for the scope of this lecture, let's go over what you need to know. Under the free tier, we'll get 750 hours on an EC2 T2 micro or T3 micro instance, depending on the region we use. Now, Amazon does have a resource where we can check the specifications of each EC2 instance type. So this is what the resource looks like. Amazon EC2 instance types, and we will be going through this in much more detail later on, so we'll just do a brief overview for now. You'll notice on the left-hand side we have different categories of instances. So if we click on general purpose, we get information relevant to the general purpose instance types. And there are a number of different general purpose instance types we can use. For now, the ones we're concerned with are T3, and T2, because these are what's included under the free tier. So by scrolling down, there's a table here, and the T2 Micro comes with 1 CPU, 6 CPU credits per hour, 1 GB of memory, EBS only storage, and low to moderate network performance rating. Okay, again, don't worry too much about what all this means. It'll make a lot more sense as we progress. For now, just know that there is a resource available on Amazon which gives detailed breakdowns for each EC2 service that's available within AWS. So again, the T2 Micro instance includes 1 virtual CPU and 2 GB of memory. We also get 750 hours of usage of a DB T2 Micro database. And this particular database includes 20 GB of general purpose SSD database storage, 20 GB of storage for database backups and DB and database snapshots. We get 5 GB of standard storage, or in other words, S3 storage. We get 5 GB of Amazon Elastic file storage, which is something we'll be using and exploring later on as well, also known as EFS. We get 30 GB of Amazon Elastic block storage, EBS. So these are the 3 main types of storage we'll be covering throughout this course: S3, EFS, and EBS. And we do get all of these products or services under the AWS free tier. So it's going to be great as we progress through the course. We'll be able to do hands-on exercises without incurring any additional charges. Data transfer into any of our storage devices is always free, so you can migrate as much data to AWS storage as you need to without ever worrying about incurring costs. The AWS free tier allows 1 GB per month of data storage out. And that'll be more than enough for anything we're going to be doing as part of this course. So we hope you enjoyed this overview of the Amazon free tier, and we'll be setting up our free tier account later on in this section. Quite often, when we open an account with a product or service, we rarely review the acceptable use policy in terms of service. If you plan on working with AWS extensively, there's a good chance you'll likely be using the services for some pretty important things. For example, you may intend to build out an application, migrate an on-premises data center, or manage client apps through a centralized account. This means you'll invest a great deal of time and resources into deploying your projects using the AWS cloud service. If you're unfamiliar with the rules, all of your hard work can become unraveled if your account is suspended or even worse, terminated for a serious violation. AWS is generally quite reasonable, and they issue plenty of warnings if you've broken one of their policies. However, for certain violations, an account suspension or termination can be immediate. You can find the AWS acceptable use policy at the link below. This is what the policy looks like, and it outlines prohibited uses of the service offered by Amazon Web Services and its affiliates. So for example, you'll want to avoid any illegal, harmful, or offensive content. You'll want to avoid security violations, avoid network abuse, no email or other message communication abuse. And towards the end, there's the monitoring and enforcement, where they let you know that they will investigate any violation of the AWS service. Now, another thing you'll note in the policy is it says quite explicitly, if you violate the policy or authorize or help others to do so, we may suspend or terminate your use of the service. So do take it seriously. So there's a few other additional legal agreements to review prior to using AWS that are quite important. For a complete list of those agreements, you can visit the link below. And we'll go ahead and just pull up that page. So this resource here covers a broad range of different legal agreements Some of them may pertain to you, some might be less relevant, but you'll want to go through them and just make sure that you're in compliance with their rules. So we can see a name of the legal agreement on the left and a description on the right. In addition to these legal agreements, you'll want to make sure that you do review the privacy policy to see how your personal data is used and protected. Since you're now familiar with the basics of AWS pricing and their terms of use, it would be a good idea to register an account, so we can start working on some of the practical, hands-on components of this course. In the lectures to follow, we'll not only explore the AWS interface, but also explore many of the services that are relevant towards becoming an AWS cloud practitioner. As mentioned in the last module, it's always a great idea to start with the AWS free tier, so we'll go ahead and get signed up. To do so, you're going to want to head over to this page. Once you're on the AWS free tier page, go ahead and click Create a Free Account. Now we'll need to enter some basic details. This includes an email address, and we'll need to select our password. So let's go ahead and do that first. We'll also need to create an AWS account name, which can be any combination of alphanumeric characters. Once that's complete, go ahead and click the Continue button. We'll now have to enter some personal details. First, you can specify how you plan to use AWS. If you're using this for business, go ahead and select business. If you're using it for personal, go ahead and do that. Once you've completed entering your personal information, go ahead and click Continue. Make sure to select that you agree to the terms of the website. Now we'll need to add a credit card for identity verification purposes. AWS will process and hold $1 to the card. Once you've entered your billing information, click Verify and Continue. Next, we need to confirm our identity through an automated text message or phone call. So select whether you want to confirm through text message or voice call. I'll go ahead and select text message. Now enter your country or region code. Enter your mobile number. You'll have to solve the security check and click Send SMS. Once you enter your verification code, click Continue. We'll now need to select our support plan. Since all our resource usage for this course will fall well within the free tier, we'll go ahead and select the basic plan. So make sure you select basic support. It should be highlighted in blue. And click Complete Sign Up. So with our sign up complete, go ahead and click the Go to AWS Management Console button. This is the main sign-in page. And anytime you come to this sign-in page, you're asked whether you want to sign in as the root user or an IAM user. We'll discuss the difference between user levels in great detail later in this course. For now, select root user so we have administrative rights to configure any and all settings in our new account. Before we enter our login information, I just wanted to show you 2 emails that you should have received from Amazon Web Services confirming the activation of your account. So this is the first email here, and the subject is AWS Support Basic Sign Up Confirmation. This is what the email looks like. Thank you for signing up for AWS Support Basic. You now have access to AWS support. And if I just return to the inbox, this is the second email. Welcome to Amazon Web Services. Thank you for creating an Amazon Web Services account. For the next 12 months, you'll have free access to core AWS compute, storage, database, and application services within the limits of the free tier. So just make sure that you did receive these emails. Now we'll go ahead and log in. So enter the email address that you signed up with. and click Next. Solve the security check. And enter the password you'd selected when you signed up, and click Sign In. So we're now on the main AWS Management Console page, which includes the following. At the top left corner, we have a Services menu, and this includes a list of services you can activate or deploy in your account. We also have a search bar. This is where you can instantly search for services, features, marketplace products, and documentation. Beside the search bar, we have a shortcut to AWS Cloud Shell. And this is the command console that we'll be exploring later that comes built into AWS. We have a notifications menu that summarizes any open issues, scheduled changes, an event log, and any other notifications. Beside that, we have a drop-down menu with administrative tools where we can manage our account, details, service quotas, billing, security, and session termination. So we can log out from here as well. This menu also contains our unique AWS account number. This is an important number, and we'll be using it for a few different things later on. The next menu over is the Regions menu. We'll also be exploring regions in more detail. For now, you just need to know that this menu here contains a list of regions to choose from. And beside that is the Support panel. The Support panel offers a number of resources that can be used for additional support while using AWS and its services. This includes things like a support center, forums, documentation, and training articles and videos. So that's the top menu in a nutshell. Below that, we also have a shortcut panel with services that we've recently visited. We also have a shortcut panel for deploying popular resources and other tools. And we have a shortcut panel for learning different aspects of AWS. Towards the bottom of the page, we also have additional learning resources. You'll notice that when we expanded the services menu in our AWS account, there was a substantial number of services there. AWS currently offers over 165 services. However, not all of them are relevant for the AWS Cloud Practitioner exam. Let's go through a quick high-level overview of the services which will be included on the exam and also that will be part of this course. So the first service is the Identity and Access Management, or IAM service. IAM allows us to create user groups and control which users have access to specified services in our AWS account. So for example, an organization may not want their developers having access to billing and security settings. IAM policies will help us control these types of permissions. In other words, who gets access to what. We'll be working extensively with IAM throughout this course. We then have AWS Compute. There are a number of AWS Compute services which will be relevant to the exam. These services provide AWS customers the ability to deploy virtual machines that power their applications. And as we know, virtual machines are composed of computational power, memory, and network resources that are attached to the machine as well, such as bandwidth. So as part of this course, we'll be exploring Amazon Elastic Compute Cloud, or EC2, Amazon Elastic Container Service, ECS, AWS Lambda, and Amazon Lightsail. In addition to AWS Compute, we also have the AWS Storage Services. And as part of this course, we'll be exploring Amazon Simple Storage Service, or Amazon S3 for short, Amazon Elastic Block Storage, also known as Amazon EBS, and Amazon Elastic File System, known as EFS, and AWS Storage Gateway. AWS networking services offer customers the ability to establish a dedicated network connection to the cloud to exchange data. They also allow customers to segregate their cloud infrastructure and scale workload requests based on usage and consumption. In this course, we'll be working with Amazon Virtual Private Cloud, or VPC, and AWS Direct Connect. AWS offers a number of database services, and they're an important part of this course. As part of this course, we'll explore Amazon Relational Database Service, RDS, Amazon DynamoDB, Redshift, EMR, Elasticache, Athena, and a number of others. And you can see a full list of them on this slide here. Elastic load balancing and auto-scaling. As part of this course, we will be exploring both. For example, ELB is a service used to distribute incoming application traffic to various network resources so they can auto-scale more efficiently and accommodate fluctuating traffic demands. Content delivery and DNS services. Under this category, we will explore two important services, including Amazon Route 53 and Amazon CloudFront. Route 53 is a scalable domain name system, DNS web service. It's commonly used to translate readable domain names into numeric IP addresses. Amazon CloudFront, on the other hand, is a globally distributed content delivery network. It delivers cached content such as videos and other bulky media from locations that are closer to end users, thus improving the speed for downloading content. So we will be exploring both of these services in detail. Monitoring and logging services. AWS is a complex cloud service. For this reason, understanding how to effectively monitor usage and performance is critical. In this course, we will explore two monitoring and logging services. This includes Amazon Cloud Watch and AWS Cloud Trail. Now, AWS defines these services as follows. Amazon Cloud Watch is a monitoring and management service that provides data and actionable insights for AWS, hybrid, and on-premises applications and infrastructure resources. With CloudWatch, you can collect and access all your performance and operational data in the form of logs and metrics from a single platform. AWS Cloud Trail is a service that enables governance, compliance, operational auditing, and risk auditing of your AWS account. Cloud Trail provides event history of your AWS account activity, including actions taken through the AWS Management Console, AWS SDKs, command line tools, and other AWS services. Notification services. Amazon Simple Notification Service, or Amazon SNS for short, is a fully managed messaging service for both application to application and application to person communication. So we'll be exploring this messaging service as part of this course. Migration and transfer. Data and server migration are two key concepts you'll need to know as an AWS cloud practitioner. We'll cover both concepts in detail. We will also explore Amazon Snowball, which is defined in the AWS documentation as follows. Snowball is a petabyte-scale data transport solution that uses secure appliances to transfer large amounts of data into and out of the AWS cloud. Using Snowball addresses common challenges with large-scale data transfers, including high network costs, long transfer times, and security concerns. Cloud governance and security. This course will introduce and explore a number of cloud governance and security services offered by AWS. We'll be providing a high-level overview of the concepts in this category, since most of them are not intricately relevant to the cloud practitioner exam. So here is a list of services that we will provide an overview for. This includes things like AWS Guard Duty, Artifact Inspector, Service Catalog, and a few others as well. So as you can see, we're going to cover a lot of material, but by the end of this course, you will be more than familiar and proficient with all of these concepts. Global versus regional services. In this lecture, we'll explore the theory behind AWS regions. The concept of global and regional services in AWS is one that we'll visit quite often. It's important to understand the difference between the two, since almost all AWS services fall under one of these two categories. This slide lists the services we explored in the last lecture based on their classification as either global or regional services. As you can see, IAM, storage solutions like Amazon S3, and DNS services like Amazon Route 53 are global services. Amazon EC2, ECS, Lambda, and Lightsail are regional services, along with storage solutions like EBS, EFS, and AWS Storage Gateway. So this is a very important thing to remember moving forward, because we'll be dealing with each of these services, and it's important to just have a high-level understanding that they either fall between global or regional services. Now, to better understand this concept, know that AWS operates clusters of data centers in different physical locations around the world, and these are known as regions. AWS also offers an interactive map which shows each of its regions and availability zones across the world. This resource can be found by visiting this link here. And I'll pull it up just to give you an idea of what it looks like. So here on this page, we can see a number of region maps. For example, North America, South America, Europe, Middle East, Africa, and Asia Pacific. So I'm going to click over to North America for the purpose of this example. And here we can see that there are 7 regions in North America. So this includes US East, Ohio region, US West, Oregon, US West, Northern California, and US East, Northern Virginia, among a few others. So each of these are different regions. And on the map, we can see that the regions are highlighted in yellow. Within each region, there are a number of availability zones. For example, US East, Northern Virginia, has 6 availability zones. You can also see when the region was launched, how many local zones the region has. And we'll talk about local zones in a moment. So now we'll talk about availability zones in more detail. Each logical grouping of data centers within a localized region is called an availability zone. As explained within the AWS documentation, each availability zone has independent power, cooling, and physical security, and is connected via redundant, ultra-low latency networks. This segregation of availability zones within each geographic region helps ensure that disruptions in one data center do not affect the other. The AWS documentation also provides the following definition, which outlines the purpose and benefits of the availability zones. An availability zone is one or more discrete data centers with redundant power, networking, and connectivity in an AWS region. AZs give customers the ability to operate production applications and databases that are more highly available, fault-tolerant, and scalable than would be possible from a single data center. All AZs in an AWS region are interconnected with high bandwidth, low latency networking over fully redundant dedicated metro fiber, providing high throughput, low latency networking between AZs. All traffic between AZs is encrypted. The network performance is sufficient to accomplish synchronous replication between AZs. AZs make partitioning applications for high availability easy. If an application is partitioned across AZs, companies are better isolated and protected from issues such as power outages, lightning strikes, tornadoes, earthquakes, and more. AZs are physically separated by a meaningful distance, many kilometers from any other AZ, although all are within 100 kilometers or 60 miles of each other. AWS also offers an extension of its AWS regions, known as AWS local zones. This feature allows infrastructure deployment from geographic locations that are in closest proximity to end users, which offers single-digit millisecond latency to maximize application deliverability and efficiency. In other words, you can deploy AWS compute, storage, database, and other select services in close proximity to large populations, industry, and IT centers. At this time, AWS local zones are generally available in Los Angeles, with plans to extend the offering to Boston, Houston, and Miami. If you'd like a breakdown of all AWS services by region, you can visit this link shown here. And I'll pull up the page just so we can go through it. So on this page, we can select each region from the drop-down menu and see a detailed listing of all services available under this region. So let's say we wanted to see what's available under US East, Northern Virginia. And you can see that there's an extensive list of services available in this region. And you can do that for any other region as well. Now that you understand some of the theory behind global and regional services, we'll go over an example use case. First, let's pull up the management console again and quickly demonstrate how you can confirm if a service falls under global or regional. So here I am back in the AWS management console. We're going to start off by typing a service into the search field. For this example, I'm going to type in IAM, because we know that IAM is a global service. So I'll go ahead and select IAM from the list. Once the page loads, if we look at the top navigation menu, you'll see here it says global. Now if you click on the menu, you'll also notice all the regional selections are grayed out. And there's a notice that IAM does not require region selection. So this is exactly what you'll see for global services. There's not going to be any region selection. Okay, now I'm going to go back to the search field and I'm going to type in EC2. Since we happen to know that this is a regional service, go ahead and click on EC2. Okay, now look at the menu again. This time we have the option to select a region before deploying this service. So this is the difference in what you'll see between global and regional services. Now let's go over a practical case study which will help you understand the premise behind global versus regional services. So let's say, for example, a software development company, it's based in Los Angeles, it specializes in building web applications, and they want to migrate their on-premises data center over to an AWS virtual private cloud. So let's define some of their requirements and considerations prior to the migration. So one of the requirements is that various personnel within the organization will require user-level access to the AWS Management Console. Each user would require a different level of permissions based on their role within the organization. Developers and in-house personnel require compute, network, and storage resources within close proximity to their geographic location, which happens to be in Los Angeles. So they want to ensure low latency, high speed network connectivity to the cloud at all times. So they want to be in close proximity from the office to the actual data center. The company would also be deploying public web-based applications on behalf of clients on virtual machines, which are in close proximity to the app's end users. So it's important that the web applications and the data center that houses them are in close proximity to the application's end users. Again, this is going to ensure low latency, high speed connectivity. Now, traffic to the apps would be directed using AWS's DNS management service, or Route 53, and Amazon CloudFront, which is a caching and content delivery service. So now that you know the requirements, okay, this is a fairly simple example. Let's take a look at how global and regional services would come into play using an illustration. We'll start off by addressing requirement number 1 and 2. We know that IAM is used to control user groups and permissions. IAM would be used to identify each member of the organization and their accessibility rights on the VPC. This would be administered at a global level since IAM is a global service. Once logged in, each member could then deploy and administer regional services granted that they have the permission to do so. To address requirement number 3, the organization could deploy computational and network resources using an EC2 virtual instance, which is in close proximity to the main office and its personnel. Since EC2 is a regional service, the administrators would have a great deal of flexibility in selecting a data center that's right for them. The company could also store its static data regionally using S3 storage. Although some settings in the S3 service are global, the service allows regional selection for data storage. This helps keep the data close to personnel to reduce latency in file transfer. To address requirement 4, web apps built on behalf of clients could be deployed on EC2 instances that are in close proximity to the end users of the app. Web traffic to the app would be managed using Route 53 and Amazon CloudFront, which are both global services. So as you can see from this example, the solution to this case would involve the deployment of resources across both global and regional services. This is often the case, so it's important to keep this in mind as we move forward. Up to this point, you've registered your AWS account, and we've explored the AWS Management Console. You've also gained some insights behind the theory of global versus regional services. Moving forward, we're going to start with some of the hands-on exercises, and before we do that, it's a good time to set up a billing alert. Earlier in this course, we spoke at length regarding the importance of understanding how billing works in AWS. We already know that without careful controls, the amount of your monthly bill could come as an unexpected surprise because of the way AWS bills based on usage consumption. This is especially true if you deploy services and experiment with tools that are beyond the scope of this course. Luckily, AWS has built-in billing alerts that will send out an email if your account exceeds a specified threshold. In this lesson, we'll go ahead and set up a billing alert. Now keep in mind, it's always a good idea to set up a billing alert. This is especially true if you're using the AWS free tier and you don't want to incur any additional fees. In order to set up a billing alert, first access your AWS Management Console. Next, from the top navigation menu, select My Billing Dashboard. Now click on Billing Preferences. We'll need to go ahead and place a check mark next to the following labels: Receive Free Tier Usage Alerts and Receive Billing Alerts. Next, enter the email address where you would like the billing alerts to be sent. Now press the Save Preferences button to ensure your new configuration is updated. With our alerts enabled, we now need to specify a budget before the alert is triggered. In other words, if our account exceeds a certain threshold, the email notification should be sent. To set this value, click Manage Billing Alerts. We're now on the CloudWatch dashboard, which is a utility used to monitor your AWS usage. From the dashboard, click Billing. We're now on the Billing Alarms dashboard, and as you can see, AWS provides a brief description of the Amazon CloudWatch service. Amazon CloudWatch can help you monitor the charges on your AWS bill by sending you email alerts when charges exceed a threshold you define. Once you update your preferences in the Account Billing Console, you will be receiving Amazon CloudWatch metrics that reflect your month-to-date AWS charges. Then, you can create a billing alarm by specifying a spending threshold and an email address to notify. You get 10 free alarms and 1,000 free email notifications each month as part of the AWS free tier. So if you exceed that amount, you will be billed for it. To create the alarm, go ahead and press the Create Alarm button. This brings us to the Metrics and Conditions dashboard. Here we can see some important information. This includes our estimated charges for this period in graph format. Since estimated charges is in fact the metric we want to use to trigger the alarm, we can leave this section as default and move to the next. Under the Conditions panel, do the following. Leave the threshold type as static and alarm conditions as greater. This will trigger the alarm when our estimated charges exceed the static value we have identified as our threshold. Now input the threshold value. Let's go ahead and set it to $10. Now hit Next. We now have some options relevant to the configuration of our notification. The service used by AWS to send the notification to your email address is the Simple Notification Service, or SNS. Since AWS allows communication messages to be shared between services using topics, we can create a new topic specifically for our billing alerts. Make sure that Create New Topic is selected. Next, we'll need to give our new topic a name. I'll go ahead and call it Billing Alarm, and you can do the same. Next, you can enter your email endpoints for this notification. You can either enter multiple emails or a single email, it doesn't matter. Now click Create Topic. Now scroll all the way down. You don't need to configure any of these additional options. Just go ahead and click Next. Okay, now we'll have to give this alarm a name. So again, I'll enter Billing Alarm. An alarm description is optional. I'll leave that empty and click Next. So we can now review the summary of information, and it was fairly straightforward. So we have our metric, the conditions we'd identified, the actions, and the name and the description of the alarm. So with that set, just go ahead and click Create Alarm. Now we're brought back to the billing alarm dashboard where we can see our new alarm appear in the table. Here we can see the alarm name, the state, when it was last updated, conditions, and actions. Now the alarm is not yet active because we haven't clicked the link in our confirmation email that was sent once we activated the alarm. So here I am in my email account, and this is the email that you will receive once you set up a billing alarm. It says to confirm the subscription, click or visit the link below. So I'll go ahead and click it. And now we can see that the subscription is confirmed. You have successfully subscribed. Okay, now back in the Billings Alarms dashboard, I'm going to go ahead and refresh the table. And now you can see that the state has changed to OK. Now you'll recall that we created an SNS topic for this alarm. So let's go ahead and check out what that looks like in the SNS service. So in the search field, type in SNS, and you're going to click on the simple notification service. So now we're on the SNS dashboard. Now under topics, you'll notice there's one topic. Go ahead and click that topic. Now you'll see the billing alarm in the topics table. So that is the SNS topic we created. Go ahead and click on it. Now underneath the subscriptions tab, we can see the topic ID, the endpoint, the status, and the protocol. So this topic will send a notification to this email address. The status is confirmed, so it is working. And the notification will be sent via email. So we've now successfully set up a billing alert, which eliminates having to worry about unexpected usage fees. So if your account ever goes above $10, you'll get a notification right away. So let's go back to the main dashboard by clicking the AWS logo. Welcome back. In this lesson, we'll be making sure our AWS root account is secure by setting up multi-factor authentication, or MFA. I'm here on the main AWS sign-in page, just to give you an example of what we're about to do. Currently, when we sign into our AWS account, you'll notice we have the option of signing in as a root user or an IAM user. Now, since we haven't created any IAM users yet, at this time, we only have root level access to the management console. So just keep that in mind for now. Now, generally speaking, you want to avoid signing in as a root user unless you absolutely have to. Root level access is the highest level of access you can have on an AWS account. With a root account, you can perform any action and launch and administer any service available in AWS. Now, though this may seem convenient, it can also pose a serious security risk. This is especially the case if somebody was to compromise your root account. For example, if your root account was ever compromised, the unauthorized intruder can cause significant damage and do things like changing account settings, deleting the entire AWS account, managing IAM user permissions, changing the AWS support plan or canceling the existing plan, activating or terminating any resource or service within the account. This includes instances, storage, and network configurations, among many other things. Keep in mind, Your storage devices may store very important applications that have taken years to build. So this is definitely something you want to consider. You want to make sure that your root account is not compromised. So in order to keep the root account safe, it's very important to enable multi-factor authentication, or MFA. This gives a secondary layer of protection to the account in addition to the standard username and password. You've likely used MFA on other services you might use, such as Gmail and Facebook. With MFA, you must provide 2 pieces of evidence in order to successfully authenticate into the system. And there's 3 main types of MFA methods. So this includes knowledge. Knowledge are things you know, such as a username, email address, a password, or PIN code. Possession. This includes items you possess that can be used to authenticate, such as a smartphone app, which we'll be installing in a moment, or an authentication device. And the third is inherence. So this includes personal traits such as fingerprints or voice recognition. So for our purpose, we're going to be focused on the first 2, which is knowledge. We already have that implemented. We enter a username and password to log into the root account. But by enabling possession as well, this will add a secondary layer of protection because we'll have to enter a code from our smartphone, which is something only we would possess. So you'll understand exactly how to do that in just a moment. So setting up MFA on your AWS root account can be accomplished in a few simple steps. In order to follow along, you'll need to download and install Google Authenticator app on your smartphone. iPhone users, you can obtain the Google Authenticator app from the Apple App Store, and Android users, you can download the app from the Google Play Store. So after we enable 2-factor authentication on our AWS account, AWS will request a code from the Google Authenticator app, which is going to be installed on our smartphone in order to sign in. This will be an added layer of security above the email and password combination that we already enter in order to sign in. In this lecture, we will provide a hands-on demonstration of enabling MFA on the AWS root account. From the navigation menu, click your account name and select My Security Credentials. We're now brought to the Security Credentials administration page where we can set up a number of different security protocols. The first you see here is password. By expanding this item, you have the option of changing the email address and password associated with your account. Next, we have MFA. Expand this tab to access the Activate MFA button. Once you click the button, a pop-up will appear with 3 different MFA devices you can use to authenticate. For the purpose of this tutorial, select Virtual MFA device and click Continue. At this point, you will need to make sure you have Google Authenticator installed on your smartphone. Once installed, launch the Google Authenticator app. Click the plus icon on the bottom left corner of the screen and click the Scan QR Code button. Now on the AWS page, click Show QR Code and use the Authenticator app to scan the code. We'll need to enter 2 consecutive codes from the app into these input fields here. Once that's complete, press Assign MFA, and you'll see a success notification appear. Close the pop-up and we can see from the MFA table that MFA is now enabled for this root account. We can go ahead and now test it out. Let's log out of the system. So click sign out. Now click log back in. Make sure root user is selected. Enter the email for the account and click next. Pass the security check. Click submit. Enter your password. Okay, so now AWS is asking for our MFA code, the multi-factor authentication code. So you're going to go ahead and launch the Google Authenticator app on your smartphone, and you're going to enter the MFA code. Now click submit. Now upon successful authentication, you will be back into the AWS Management Console. So that's all there is to it. MFA is now enabled on our AWS root account, so the account is much more secure. In the last lecture, we explained the importance of securing the root account and accessing it only when absolutely required. We also explained that it's much better practice to create individual user accounts and assign access permissions based specifically on what the account will be used for. In this lesson, we'll be doing exactly that. We'll create an individual IAM user and assign permissions. So let's go ahead and get started. To get started, from the AWS Management Console, type in IAM into the search bar. IAM, or Identity Access Management, is the AWS service that lets us administer our user accounts. So go ahead and select IAM. This now takes us to the IAM dashboard. From the dashboard, click Users. Here, we have a table with a listing of our current users. We can also see any groups the user is assigned to, the age of the user's access key, the last time this account was used to access an AWS service. So currently we have no information because we don't have any user accounts except for our root user account. So let's go ahead and create a user. Click Add User. Next, we need to assign this user with a username. For the purpose of this lesson, you can call the user anything you like. I'll go ahead and enter John. In the next section, we need to specify the AWS access type that we want to grant this user. We have the option to give programmatic access and console access, or one or the other. We're already familiar with console access because we're already using the AWS Management Console. But programmatic access is a new concept. We'll be exploring that later on. Programmatic access allows the user to access various AWS development tools through clients like PuTTY, Terminal, Console, and AWS CLI. If you're unfamiliar with these tools, don't worry. We'll be working with them in future modules of this course. So for now, just go ahead and give this user both access types. Once we enable console access, we'll need to specify a password. So go ahead and type in a password for this user. I'm going to select a custom password. You can use auto-generated if you like. Now for added security, you can leave this option enabled. So what this will do is when we log back in using these account credentials, we'll need to reset the password. Okay, with that complete, go ahead and click Next, and we're going to go over permissions now. We're now presented with a few additional options. We can add the user to a group. We can copy permissions for this user from an existing user. We can attach existing policies to this user. A user group allows organizations to assign multiple users similar access rights and permissions. So that is something we want to do. Let's go ahead and create a group for this new user. Click Create Group. We now have the option to name this group and either assign an existing policy or create a new one. For now, we'll assign the Administer access policy that provides full access to AWS services and resources. So place a check mark next to Administrator access. You can expand this policy item, and under the policy summary, so make sure that that is active, you'll see all the services that the user can now access, which are included as part of this security policy. So they have access to 277. So this user will be an administrative level user, which is what we want. I'm going to call the group admin group. You can call it whatever you like. I'm just arbitrarily choosing this name. I'm going to go ahead and click Create Group. Okay, so you'll see that our group is now appeared in the table down here. This is the name of the group, and this is the security policy that's attached to this group, and that security policy is going to govern the rights and permissions that this user has on our AWS account. Okay, so with that done, you can go ahead and click Next. We now have the option to assign tags to this user. This can include information like the user's email address, job title, or other descriptive information. Just for the sake of this example, let's go ahead and create a tag. We'll call it title, and as the value, we'll call it administrator. So the key, for example, is the job title, and the value is the administrative role that we've assigned to this user. But you can think of a number of other ways you could use tags. With that done, you can go ahead and click Next. Okay, we can now review the information for this user, and it's pretty straightforward. I'll go ahead and click Create User to finalize. So we now have a success confirmation message along with the user's credentials. The access key ID and the secret access key are very important. These credentials are needed for programmatic access to AWS's development tools. Once we click the Show button here, the secret access key will only be displayed once. It can never be accessed again through the AWS Management Console. So for this reason, you should download this information in CSV format and store the file somewhere safely. A few other important tips. These credentials should never be shared with anyone. Unauthorized access using these credentials would allow full administrative access to AWS developer tools, which can be very dangerous. So remember, the security policy attached to the group that this user belongs to has access to 277 services. This access key and the access ID, the combination of these two, can be used to access any of those services within this account. So you certainly don't want to share this information with anyone. I'll go ahead and click Show just to give you an idea of what the secret access key looks like. Okay, so now I'm going to go ahead and download the CSV because we will be using these credentials later on. So I went ahead and saved the credentials to a safe place on my computer. And now we're going to go ahead and click close. We're now back onto the user's dashboard. Go ahead and click admin group, the group we just created. We want to access it, so click on it. So here we can see a summary of the group, which currently consists of one user. And so there's our user, John. If we wanted to remove this user from the group, we could click on remove user from group. We can also access the permissions tab. And here we can see the permissions assigned to this user. Listed here is the policy we attach to this group called Administrator Access. So this group and all the members within this group have access to the services and resources granted within the Administrator Access policy. Now click Access Advisor. The Access Advisor tab, this gives us a full list of permissions under the policy attached to this group. It also tells us when each individual service was last accessed by users of this group. So right now, none of these services have been accessed within the tracking period. But if they were, we would have seen the user's information, the username pop up in this column here, where it says accessed by members. Okay, so that's the group summary in a nutshell. We'll be working with this quite a bit throughout the course, so you'll definitely become much more familiar with it as we move forward. We're now going to navigate to the users dashboard, so click users. So here we have a listing of all the users that we've created in our AWS account. We only have one at the moment, user John. Okay, so click John. And now we can see a summary of this user the same way we just did with our groups. So here we can see this user is attached to the Administrator Access policy. Okay, this policy was attached to the admin group we created earlier. Now if we click over to tags, okay, this user has one tag which we created earlier. The tag key is title, the tag value is administrator. Now click security credentials. Here we can see the user's access key ID. We can see when it was created and when it was last used. We also have the option of making this key inactive so it can no longer be used. Now you'll notice that we can't see the secret key anymore. So again, that only appears once. That's why we save that file and sort it to our computer. Okay, click on Access Advisor. This tab here provides a listing of all services that can be accessed by this user. All the services here are what's included in this Administrator Access policy, which is attached to the group that this user belongs to. In this lecture, we'll configure a custom sign-in link for our IAM users. Although this step is not a requirement, it offers a more convenient way for IAM users to log in. The link can also be branded for your organization, which gives a better overall look. So let's go ahead and get started. First, you're going to have to go back to the IAM dashboard. So just click Dashboard here. And you'll notice there's a custom link which can be used by IAM users to sign in to their account. So this is the link here. The default link includes a numerical access ID which can be customized for our organization. So it starts with 8 and ends with 7. That's the entire access ID there. To customize it, click the Customize link. And we'll have to enter the preferred alias for the account. So I'll just type in myco003. Again, you can enter whatever you like there. AWS will double check to make sure that this account alias is not already in use, so it does have to be unique. Once you've entered the alias, you'll see a preview of the new URL here. So this will be the new sign-in URL. You can see that the access ID has been replaced by our preferred alias. Now click Create Alias. Okay, now go ahead and copy this link. And we can sign out of the root account now, since we no longer want to use the root account for some of the things we're going to be doing moving forward. We're going to be using the user we created. So go ahead and expand the account menu and click Sign Out. Now you're going to paste the link we copied into the browser. We'll enter the IAM username, which was John. And you'll see that the account ID is already filled in for us because we copied that link, and enter the password you'd selected for the new user we created. And press sign in. Okay, so now we're prompted to enter a new password for this user. And the reason this has happened is because we had opted for this to happen when we initially created the user. This is a good practice because generally speaking, if you are the root account owner, you want to give your IAM users the ability to change their own password to a customized password when they initially log in. You don't necessarily want them to be using the password you created for them. Okay, so just type in the old password. Now type in the new password. And click Confirm Password Change. Okay, now if you look at the top menu again, you'll notice that we're now logged in as John. So it shows up as John at myco003. So that confirms that we are logged in to our new IAM user's account versus the root account. And so that's all there is to that. We've now successfully created a new administrative user account which can be used instead of the root account. And as an added exercise, if you'd like, go ahead and enable multi-factor authentication on this new IAM account. In this lesson, we'll configure a password policy for our AWS account as an added layer of security. Since you want to be sure that each IAM user on the AWS account uses a strong password to sign in, it's important to set up a password policy. The policy will govern the password format that must be used when an IAM user account is created. So let's go ahead and get started. So back on our AWS Management Console, from your recently visited services menu, click IAM. Now click Account Settings under the Access Management heading. Under Password Policy, click Change Password Policy. Here we can specify the criteria of the password format by enabling or disabling various options. The settings you use will depend on your desired level of security, but here's a good default that you can use. You'll definitely want a minimum of 8 characters, at least 1 upper and 1 lowercase letter, and at least 1 number and 1 non-alphanumeric character. So with that set, you can go ahead and click Save Changes. And you'll get a success message that says the password policy was updated. So that's all there is to it. We now have that added layer of security for any IAM account that is created from this point forward. I'll head back to the AWS Management Console. Welcome back. This section will provide an in-depth overview of Amazon Elastic Compute Cloud, EC2. The EC2 service is an essential building block in becoming an AWS certified cloud practitioner. We will start with exploring key concepts relevant to EC2, followed by a hands-on practical guide to deploying compute services on AWS. The term scalable cloud computing has now become synonymous with Amazon Web Services. For nearly a decade, AWS has been powering some of the world's most popular websites and applications. This section explores Amazon EC2, which is considered the computational backbone of AWS. To better understand how EC2 works, we'll need to refer back to our discussion on virtualization. We know that virtualization is the process of creating a software-based virtual representation of a server. When we deploy an EC2 instance, we're creating a virtual representation of a physical server and its resources. Resources include CPU, memory, storage, and network resources such as bandwidth. Similar to physical servers that you might find on-premises, virtual EC2 instances can also have different configurations. As a matter of fact, AWS offers the most comprehensive configuration options when it comes to deploying virtual servers. Not only that, but these configurations can be easily adapted to different resource needs and in real time. The level of customization a cloud provider can accommodate will define the sophistication level of its overall service. Not all cloud services were created equal. AWS is known to have the highest level of configuration options when compared to just about any other cloud service. The AWS platform caters to both micro and enterprise level clients using one of the most scalable and advanced virtualization infrastructures available. To understand the benefits of virtual server deployment, consider the traditional method of housing servers on-premises versus virtual servers. When the resource needs of an on-premises server, such as CPU, RAM, disk, and bandwidth, exceeded the data center's capabilities, upgrades would be required. The upgrade would include replacing individual components or adding additional servers altogether. This would also require more space to house additional servers as the resource needs evolved. With AWS, virtualization eliminates many of the headaches with on-premises data centers. It also allows an administrator to allocate any additional resources to a virtual machine at the click of a button. Since virtualization is a software-based solution, it sits between the hardware infrastructure and the application. The virtualization process can extrapolate nearly an infinite amount of resources from the totality of physical hardware within a data center and assign it based on needs in real time to each tenant using the cloud service. Beyond the physical hardware customization and scalability, virtualization also accommodates the deployment of any operating system on the virtual machine. As you'll see later in this course, we have the flexibility of deploying both Linux and Windows servers. This will be done using a variety of pre-configured virtual applications known as AMIs, or Amazon Machine Images. In this lecture, we'll go over some of the core features of AWS Elastic Compute Cloud, EC2. EC2 instances are scalable virtual computing environments. AWS offers pre-configured software packages that include an operating system and other applications that are installed on deployment. These templates are known as AMIs, Amazon Machine Images. There are a variety of configurations for instances known as instance types. The configuration includes its CPU power, memory, storage, and networking capacity. An EC2 instance can be accessed remotely using an SSH client. Secure login information is stored in key pairs, which consist of a public key stored by AWS and a private key stored by you. An EC2 instance can have multiple types of storage volumes, both temporary and persistent. A temporary storage volume is known as an instance store volume because all data is deleted from the storage when the instance is stopped, hibernated, or terminated. EBS, or elastic block store volumes, offer persistent storage for data that is not to be deleted when an instance changes its operational state. Instances and volumes can be launched in multiple regions and availability zones. Firewalls can be configured through the AWS Management Console. This helps secure and control protocols, ports, and source IP ranges that can access the instance using security groups. When deployed, each instance has a dynamic IPv4 address. This IP can be detached from one instance and attached to another at any time. This feature is known as an elastic IP. It's also important to note that Amazon EC2 service consists of several capabilities, which include the following: deploying multiple virtual machines known as EC2 instances, storing data on both persistent EBS and temporary drives known as instance store volumes, distributing network load across multiple EC2 instances through ELB or elastic load balancing. The EC2 service also comes with the ability to scale using auto-scaling groups or ASG. These points cover most of the concepts you'll need to know regarding EC2 instances before we get started on the hands-on practical guides. Similar to an on-premises server, an EC2 instance can be configured with different types of virtual hardware. Each instance type offers the ability to customize computational power, memory, storage capacity, and network resources such as bandwidth. As mentioned previously, each one of these components can be individually or collectively scaled up or down almost infinitely at any time depending on application requirements. When it comes to instance types in AMI virtualization, there are a substantial amount of configuration options available. Instance types fall into the following categories: general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. AWS offers a detailed overview of each instance category on their website. I'm going to go ahead and pull up the page so we can take a look. So here I am on the Amazon EC2 instance types resource as provided by AWS on their website. So the first thing you'll notice is on the left-hand side, these are the categories that we mentioned earlier: general purpose, compute optimized, memory optimized, and so on. As we click on each one, we'll notice that the information on the right-hand side is updated as well. Each category on the left has subcategories, which are presented on the right. So for example, if I go back to general purpose, you'll notice that we have Mac, T4G, T3, T3A, T2, and so on and so forth. So there's quite an extensive array of options when it comes to selecting an instance type and the different configurations available. So the general purpose configurations are most commonly used for standard applications. They offer 12 configuration options. So these are the 12 configuration options at the top here. Now for the purpose of this course, we'll switch over to the T2 tab. And this is because the other configuration options are simply too powerful for the projects that we'll work on during this course. And also, most of these fall out of the free tier. So we want to make sure we stay in the free tier. And for that reason, the T2 and the T3 micro instances are what we're going to be focused on. Now, as you can see in the description, T2 instances offer a baseline level of CPU performance. They are a good choice for general purpose workloads, including microservices, low latency, interactive applications, small and medium databases, virtual desktops, development, build and stage environments, code repositories, and product prototypes. So although it is on the lower end of performance when compared to some of the higher end instant configurations, it can still be used for a number of different things. So it's more than what we need for our purpose. You'll most likely be working within the T2 instance range until you start deploying more sophisticated resource-intensive apps. Now I'm going to scroll down here, and you'll see that the T2 micro instance, which is what we're concerned with, it offers one virtual central processing unit. That's what vCPU stands for. 1 GB of memory, an EBS-only storage option. This means the instance does not support temporary instant store volumes, which is something we'll talk a little bit more about later. And the network performance overall is low to moderate. Now keep in mind it's all relative. Low to moderate doesn't mean it won't power your applications. It just means that it doesn't perform as well as some of the higher end Amazon EC2 instances. For example, what we might find in accelerated computing and memory optimized, which are a lot more expensive but offer a higher degree of power as well. I'll go ahead and click on compute optimized just so you can see the difference in performance between something like a general purpose EC2 instance versus compute optimized. Now here we can see in the description, compute optimized instances are ideal for compute bound applications that benefit from high performance processors. Instances belonging to this family are well suited for batch processing workloads, media transcoding, high performance web servers, high performance computing, scientific modeling, dedicated gaming servers and ad server engines, machine learning, inference, and other compute intensive applications. So right there from the description, you can see that this is meant for much more resource intensive applications than what we saw in the general purpose instance types. Now scrolling down to the specs here, this instance category clearly offers far superior performance with a maximum vCPU range of 64 and 128 gigs of memory. So that's the highest performing EC2 instance in this category. It's called the C6GD.Metal instance. Some of the names can be a little bit tricky to remember, but you can always refer to this page. So you can compare these specs. So 64 vCPU, 128 gigabytes of memory, 2 times 1900 NVMe SSD drives, 25 gigabytes per second of bandwidth. And let's compare that to the general purpose again. If we scroll down, we'll notice that under the T2 category, the highest performance we'll get is memory. So there's quite a substantial difference there. Okay, if we click on accelerated computing, let's take a look at what we have here. Okay, we can see that the specs just get exponentially higher. So here we now have this instance types, which is the P4D.24 extra large, and it comes with 8 GPUs, 96 virtual CPUs, 1,152 gigabytes of memory, and so you can see that this is a substantial increase from the previous two that we looked at, and it just gets more and more powerful from there. So as you can imagine, if you were to go through each one of these categories and their respective subcategories, AWS offers some of the most robust set of configuration options available when compared to other cloud services. This is especially the case if you're coming from a smaller provider like DigitalOcean or Linode. AWS it's an entirely different category, and there's a lot more learning involved here. And that's why it can certainly seem overwhelming at first. But as you get the hang of it, having all these options actually becomes beneficial, and it's something that you'll certainly want to have once you get into building more sophisticated applications. Now, the good news is that regardless of which configuration here you initially choose, you can always upgrade or downgrade at any time at the click of a button or even programmatically. So we'll demonstrate how this is done later in this course, but do keep that in mind. One of the benefits of a scalable cloud hosting solution is you can anticipate how much resource you'll need, select an EC2, and then later decide, okay, I made the wrong decision, I want to scale down or I want to scale up, and it's very easy to do. Okay, well, we hope you enjoyed that lecture, and in the next lecture, we'll talk about Amazon machine images. Welcome. In this lecture, we will explore Amazon machine images. When an instance is deployed on EC2, the information required for its initial configuration is stored on an AMI, or Amazon machine image. For this reason, an AMI must be specified when the instance is launched. An AMI contains the following information. AMIs are categorized as either backed by Amazon EBS or backed by Instance Store. An AMI deployed using Amazon EBS is done so using an EBS snapshot. A snapshot is a point-in-time copy of an Amazon EBS volume. An AMI launched from an instance store is created using a template stored in Amazon S3. In both cases, the EBS or instance store contains the data regarding the operating system, application server, and applications to be installed on instance deployment. Differences between deploying instances using either of the two methods we discussed can be found at the following link. An AMI will also contain launch permissions that specify which AWS accounts can use the AMI to launch instances. Launch permissions fall into three categories. This includes public. This is where the owner grants launch permissions to all AWS accounts. Explicit. This is where the owner grants launch permissions to specific AWS accounts. And implicit. The owner has implicit launch permissions for an AMI. An AMI also contains a block device mapping which specifies the persistent storage volumes to attach to the instance once it's launched. This means when a snapshot is taken, it stores information regarding each volume that is attached to the instance. When selecting an AMI for deployment, the following configuration options can be specified: the AWS region, the operating system, the computational power, memory, and storage space, the network card, firewall rules with security groups, the architecture, whether it's 32-bit or 64-bit, any associated launch permissions, and the storage for the root device, whether it's EBS or instance store-backed AMI. AMIs generally fall into one of three categories. This includes AWS Marketplace AMIs. These are AMIs which are deployed by third parties and made available for use on the AWS Marketplace. There is normally a cost associated with using an AWS Marketplace AMI. The second is community AMIs. These are free AMIs which are deployed as community-based projects. They are normally backed with an operating system and additional software which can be used under a general license. And the third category is My AMIs. These are AMIs which are created by you. That concludes our introduction into Amazon Machine Images, and later in this section, we'll be deploying our own instances using AMIs. Since you now have a better understanding of the theory behind Amazon EC2, it would now be a good time to gain some hands-on experience. Before we explore the EC2 management dashboard, let's go ahead and log back into our account and create an IAM user that will be used to administer our EC2 instances. Since my previous session expired, I'll need to log back into my AWS account. So I'm going to click log back in. And the account ID was myco003. The username I'm going to be using is John because that's our main administrator account. I'm back into the AWS Management Console. And since we want to create a new IAM user that'll be used to administer our EC2 instances, I'm going to navigate over to IAM. I'm going to go over to Users. I'm going to click Add User. And for the username, I'm going to name it First EC2. I'm going to give both programmatic and AWS Management Console access. I'll enter a custom password. And I'm going to disable the password reset feature. We're going to head over to permissions. I'm going to add this user to the existing admin group, which will give administrator access permissions to this new user. Okay, I'm not going to give any tags. I'm going to go ahead and click Next. And we're going to click Create User. Now I'm going to go ahead and save the user's access keys onto my computer. And I'm going to store those keys in a safe space. Now I'm going to go ahead and click Close. And that's going to take me back to the user's dashboard. Okay, so now we're going to log out of this user and we're going to log back in as the user we just created, First EC2. So just keep in mind that username, First EC2. Now log back in. Account ID is myco003. And sign in. So we can confirm that we're logged in as the user we just created. You can see here at the top right, First EC2 at myco003. Okay, we're now going to access the EC2 service. I'm just going to go back to the AWS Management Console. I clicked on the EC2 service from the recently visited services. If you don't see that on your dashboard, what you're going to have to do is just type in EC2 in the search bar and click EC2 from the services dropdown. In this lecture, we'll provide a comprehensive overview of the Amazon EC2 dashboard. On the left side of the dashboard, we have the main navigation menu for the EC2 service. The menu is segmented into a few important categories, which includes instances, images, elastic block store, network and security, load balancing, and auto scaling. We'll be working with each of these in this section of the course. In the center of the EC2 dashboard, we have a summary of specific resources deployed under the EC2 service for the current region, which happens to be US East, Northern Virginia. So for example, we have the instances we currently have running, the total instances, including those that are shut down, elastic IPs associated with this service, key pairs we may have generated, snapshots we may have created, and volumes we may have created. If you don't see a full list of the summarized items as we see here, click on Settings, and you can enable them from this checklist. Scrolling further down the page, we have a shortcut button to launch a new instance. If we were to click that button, we would be launching the instance in our default region, which is currently Northern Virginia. To switch regions prior to launch, we can access the top region menu here and select a different one. Beside the Launch Instance shortcut menu, we can see a summary of the service health of services within our current region. The green check mark suggests that all services within this region are operating normally. We can click on the Service Health dashboard for a more detailed summary of all services within each region. Here we have a detailed status report for each service within each region. A green check mark next to the service indicates that the service is operational. You can see that there's an extensive list of services within each operational zone. Now below the Service Health panel, we also have a listing of availability zones within our current region. In the Northern Virginia region, there are 6 zones currently enabled. We can see the zone name and zone ID. To see available zones in other regions, we can switch from Northern Virginia to, for example, US East, Ohio. And we'll give it a second to load. Now we can see that the table here has updated to show availability zones in the US East, Ohio region. So this is an example of how all of these values are based specifically on the region. I'm going to switch back to US East for now. On the right side of the dashboard, we have some additional panels, most of which offer shortcuts to exploring AWS features and some general help guides. You can go ahead and explore those if you like. So this concludes the basic overview of the dashboard. As you can see, it seems a bit overwhelming at first, but everything is laid out quite logically. Each resource and setting will also make much more sense when we deploy and configure our first instance. Now that you understand the basics of exploring the EC2 dashboard, let's go ahead and create our first instance. In this lecture, we'll cover the following concepts: launching an instance and deploying an AMI, which includes the Linux operating system and some standard applications, deploying a website using EC2 user data, and performing basic administrative actions on the instance. Let's go ahead and get started. Here we are back on the EC2 dashboard, and the first thing you're going to want to do is make sure that your region is consistent with what we have here, US East, Northern Virginia. Normally you would select a region that's closest to your end users. This helps ensure fast load times and low latency. However, for learning purposes, you want to make sure you just have what's consistent with what we've said here. Now from the Launch Instance panel, click the Launch Instance button, and then from the submenu, click Launch Instance. Right away, you'll see a number of items we touched on earlier in this section. From the left menu, we have the option to select which type of AMI we want to deploy on this new instance. For example, My AMIs, AWS Marketplace AMIs, and Community AMIs. Since we don't have any AMIs that we've built and we don't want to pay for AWS Marketplace or Community AMIs, place a check mark next to Free Tier Only. We're now presented with a number of options regarding the type of operating system we want to deploy on our instance. Generally, the operating system that you deploy will depend on the use case of the instance. For example, Ubuntu is very commonly used for running web applications. Now, for our purposes, we're going to go ahead and work with the Amazon Linux 2 AMI. We can see that the root device type associated with this AMI is EBS, General Purpose SSD Storage. And this is what we want since the volume offers persistent storage rather than temporary. This means the instance can be turned on and off without having to worry about data loss. On the right side, select the 64-bit x86 option and click Select. We're now prompted to select an instance type. Again, this table should look familiar from our earlier discussion on instance types. We can filter instances by instance families and generation. You can scroll through the list and view the various types of instances available if you like. Again, most of these should look familiar when we explored this table earlier in the course. We want to make sure we select an instance that is free tier eligible. And since the correct instance is highlighted by default, we can proceed to configuring instance details. So just make sure that you have the T2 Micro free tier eligible instance selected here and click Next. We're now presented with a number of configuration options for our instance. We don't need to go over each one since many of them will be covered later in this course. But the first thing we have here is the number of instances we want to launch with this specific configuration. And by default, it's set to 1, which is correct. Be careful not to accidentally input a higher value in this field. Now you can ignore this launch into auto-scaling group option. Again, auto-scaling will be covered in detail later on. And next we have the networking options, which can also be left as default. We want to launch this instance into our default VPC without creating a new one. We're also fine with the default subnet in any availability zone with the default subnet IP settings. Now continue scrolling down until you reach Advanced Details. Here we have the option to input some user data. As you can see, it's optional. User data can be used to input scripts that will execute on the deployment of each instance that is created using the configuration settings we've specified here. So in this example, we'll be using user data to create an HTML page that displays a line of text when we access this instance through our web browser. So you can think of it as a very simple web page that will automatically be deployed when this instance is deployed. So we're going to enter the following block of text into the user data field. And here's a summary of what we're executing here during instance deployment. So first we're telling the Linux operating system to invoke the specified shell to execute our script to follow. From there we use the yum command to update the binary packages on our operating system before installing HTTPD, which stands for Hypertext Transfer Protocol Daemon, also known as the Apache server program. After that, we execute another yum command to start and enable Apache on our instance. We use the cd command to change into the web root folder of our web server, and from there we use the echo command to create a file called index.html, which will display the quoted text seen here. This is my first web page on EC2. If you're unfamiliar with Apache, for now just know that it's a web server software package which contains essential services and utilities to host websites and web applications on our server. Apache interprets HTML files as the default file type to display when the web root folder is accessed through standard web protocols like HTTP or HTTPS. So that's what this user data is going to do for us. You can see that it's completing a number of operations automatically once this instance is deployed. So with that complete, click Next to add storage. Here we have the option of modifying the volume settings for our root volume, and the root volume is the default storage which will be attached to our instance. We can specify things like the size, the volume type, and encryption method. We can also specify if the storage data should be deleted on the termination of the instance. In addition to the root volume storage, we can also add additional EBS volumes. However, we can do this at any time, so there's no benefit or reason of doing this now. So we can leave all the settings as default and click Next. So here we have the option to add tags, and similar to when we added IAM users, we can assign tags to our instances. This helps keep instances organized if you have several different ones for different purposes. Since our case is simple, we can go ahead and create a tag just for learning purposes. So go ahead and click Add Tag and enter an identifying key. So for example, let's enter department, which will be the identifying key for this tag. And for the value, enter developers. Now these values could have been anything else. For example, if this instance was to be used to store financial records, we could set the value of the key to finance. We have the option of specifying the resources that this tag will be applied to, including instances, volumes, and network interfaces. So we'll keep them all selected, which is the default, and click Next. We're now prompted to configure security groups for this instance. We're now prompted to configure security groups for this instance. Security groups are very important since they help keep your instance secure through a firewall. They can be used to control the type of network traffic that can access resources on the instance. Although we'll be configuring some settings here, we do have the ability to configure firewall settings even after the instance is deployed. So the first thing we're going to do is select Create a new security group, since we don't have one yet. We can leave the security group name and description as default, since it's our only one for now. And in the table, we can see that the SSH rule is enabled by default. This is needed to access our instance and issue commands using Secure Shell. Later on, we'll use an SSH client to connect to our instance remotely, so we'll definitely need SSH access. Since we want to view a web page delivered through Apache on our Linux instance, we'll also need to enable HTTP. Remember, publicly accessible web pages are viewed either through the HTTP or HTTPS protocol. If our server did not have HTTP enabled, our web page would not be accessible because our firewall would block the request. So we're going to go ahead and click Add Rule. And you're going to select HTTP from the list. And next to the rule type, you'll see the protocol used by the rule, as well as the port range. Source allows us to specify whether traffic to our instance should be only permitted by specified IP addresses or an IP range. The default value allows traffic from any IP or range. Generally, it's a good practice to only allow SSH traffic from trusted IP addresses, for example, your work or home IP. However, for now, we'll just leave the default settings and click Review and Launch. You'll see that AWS displays a warning indicating that the security group attached to our instance is open to the world. This is because we didn't specify an IP or IP range for SSH access. Now again, this is okay for now, but it's certainly something you'd want to do for production or in any other situation. We can go ahead and review this summary, and everything looks good. So I'm going to go ahead and click Launch. We now need to create a key pair for programmatic access to our instance from an SSH client like Terminal if you're using a Mac, or PuTTY if you're using Windows. This is definitely something we're going to need. SSH stands for Secure Socket Shell and provides a secure way for us to connect to our instance remotely and execute command lines. And this is an essential concept to understand. It's something you will likely be doing quite often as an AWS cloud practitioner. A key pair consists of a public key and a private key. The public key is stored by AWS and the private key is stored on your local computer. When connecting to our instance, there will be a handshake between the public and private key in order to authenticate. Without a key pair, we would be restricted to authenticating with a plain text password, which is a very bad practice and quite insecure. Since we don't have any key pairs on file, select the second option here, create a new key pair, and enter a name for the key pair. I'll type in demo instance and click download key pair. So the key pair is downloaded and stored as what's known as a PEM file. A PEM file is commonly used to store cryptographic keys. We'll use this later on to authenticate with our SSH client, so don't worry too much about it for now. But what you do want to do is make sure you save this file in a secure location and you do not lose it. So I'm going to go ahead and do that. I'm just going to shift this file over to my folder, which contains a list of other important files. And the last step here is to just click the Launch Instances button to deploy the instance. So this is just a launch status summary. Your instances are now launching. The following instance launches have been initiated. So once you've reviewed that, you can go ahead and click View Instances. And we can see that the instance state is pending, and it'll just take a couple of minutes before it's running. So we can see that it's changed from pending to running, which tells us that the instance is completely configured and operational. And if you ever need to update the status here, you can just press this refresh button. In this lecture, we'll be exploring the EC2 dashboard, which provides some valuable information regarding the EC2 instances we have running in our current region. So let's go ahead and get started. Now here we are on the EC2 instances console, and here we have a listing of all the instances we currently have under our region, which in this case is US East, Northern Virginia. And you'll want to look in the instances table. Starting from the left, we have the name of the instance. Now this instance hasn't been named yet, so we'll go ahead and give it a name by clicking on this icon and typing in demo instance. Now the name can be any alphanumeric name that you'd like to give it. Next we have the instance ID, followed by the instance state, the instance type. If you recall, we launched the T2-micro instance to begin with, and that's what we see here. We have the status check. If there was any issues in the deployment of this instance, you'd see it here. But if the instance has successfully been deployed, you'll see a green check mark and the label checks passed. Now, alarm status refers to any alarms we've configured based on the activity and performance of this instance. So we haven't configured any alarms yet, and we will be later on in this course. So for now, just don't worry too much about that. We can see the availability zone that this instance is currently running in, US East-1C. Then we have the public IPv4 DNS and public IPv4 address. So that's the IP address for this instance. We'll take a look at what happens when we access this IP address from our web browser a little bit later on in this module. But for now, we're focused on learning more about our instance before we work with it. To get more information about this instance, go ahead and click on the instance row. And at the bottom here, you'll notice you get a lot more information. Now, all the details of this instance are categorized into 7 different sections, from details right up to tags. So these are all different tabs. The details section includes most of the same information as what we'd seen in the instances table. If you click on the security tab, this includes information about the AWS owner of the instance, pertinent security details, and any associated security groups for this instance. Okay, and we'll be exploring a lot of the information included in these other tabs as we progress through the course, so we don't need to necessarily go through each one of them right now. For now, we're mostly concerned with the details tab, so go back to the details tab, and we're going to scroll down and look under the instance summary. Now, you might recall that when we launched this instance, we inputted some user data to install Apache, which is our web server, and we'd also created an HTML file. So that was all done with the user data we'd plugged in when we initially deployed this instance. Let's go and see what happens when we access our public IPv4 address in our web browser in order to load that HTML page we created. So just click this button here, and that's going to copy the public IPv4 address. Now, the next thing you're going to do is just open a new browser tab, and you're going to paste that IP address into your browser and hit enter. And you'll notice it pulls up the text, "This is my first web page on EC2." So that's the same message that we'd inputted into the user data. So now we know that our instance is not only operational, but the web server is active and it retrieved this HTML document on the HTTP protocol. So we can confirm it was in fact on the HTTP protocol by typing in HTTP, enter, and it pulls up the same page again. Now watch what happens if you type in HTTPS. Okay, you'll notice that the wheel just keeps spinning here and the page will not load. So this page is currently only active on the one port we'd opened in our firewall, which is the HTTP protocol, port 80. Okay, so back over to the EC2 console. In addition to our public IPv4 address, we also have a private IPv4 address. This private address is used to identify instances within the same virtual private cloud. So you can think of it like this. When you have multiple computers connected within an office or home to the same network through a router, each of the devices is assigned a unique IP. This is the same concept with AWS. So in addition to the public IP, the private IP identifies instances that belong to the primary AWS account within the grander AWS cloud service. And that essentially is your VPC within the AWS cloud service. We can also see some additional information regarding our VPC. This includes the private IPv4 DNS, the VPC ID, and the subnet ID. We'll work a lot more with VPCs later in this course. Now, one important note is that the private IP addresses can be used to rapidly transfer data between instances in the same region. This is because the VPC uses the internal AWS network infrastructure. So data transfer is a lot faster within AWS's internal network. The public IPv4 DNS is simply a human-readable version of our public IPv4 address, it can be used in a web browser to access our web server, just like the numerical IP can. And if you'd like to go ahead and confirm that, you can just copy the IPv4 DNS, open a new browser tab, type in the HTTP prefix, and paste the address and press enter, and it pulls up the same page as our IP did. Another important consideration you want to keep in mind is that this IPv4 address will change every time the instance is stopped and restarted. I'll go ahead and show you what I mean. I'm going to right click on the instance here and just click Stop Instance. So I'm going to go ahead and stop it. Okay, so you can see that this instance has stopped. And now when I go ahead and restart this instance, watch what happens to the public IPv4 address. Now I do have to keep pressing this refresh button just to see the instance state. So once you change the state, it takes a couple of minutes, maybe a few seconds to change over. So right now it's pending, so it hasn't finished starting yet. Okay, so the instance is now running again. So we stopped and restarted it. Now if I click on the instance, okay, the IPv4 address is still not showing, so it'll still take a little bit more time. Okay, there we go. So now the public IPv4 address has changed. It's a completely new IP address from what we had before. Now this is fine if you're not running a website off this server with the registered domain name. But if you do have a little bit of background in running web applications or any application that's accessible through a web browser and through a registered domain name, you'll know that you don't want the IP address here to constantly keep changing on you. So in order to prevent the IP address from changing, we're going to explore what's known as elastic IP addresses. And that's going to prevent the IP address from changing. And we're going to cover that concept in the next lecture. So we'll see you in a bit. In this lecture, we'll explore the elastic IP feature offered by AWS. We'll start by going over the characteristics of an elastic IP to help you gain a better understanding of this concept. An elastic IP is a reserved IP which is assigned to your account on creation. An elastic IP can be associated or disassociated from EC2 instances. An elastic IP is transferable between EC2 instances within a particular region. Your build for elastic IPs which are not associated with an instance. An elastic IP can be easily deleted once created. Before deleting an elastic IP, it's a good practice to confirm it's not associated with any operational instance. Now let's go over an example use case for an elastic IP. Say for example a developer deploys a production server. We'll call it instance 1. He uploads a web application to the server. The developer then creates an elastic IP and attaches it to instance 1. He then configures his domain DNS zone record so the domain name resolves to the elastic IP and not the standard IP that comes when an instance is deployed. Later on, the developer decides to make significant updates to the application on the web server. Since it's never a good idea to make big updates on a production server, he replicates instance 1, and the instance replica is called instance 2. The developer makes the site updates on instance 2. Once the updated application is complete, all the developer needs to do is disassociate the elastic IP from instance 1 and associate it to instance 2. Users will now be accessing the web app on the new instance 2. This means zero downtime for the changeover since the IP always remains the same. This is just one example of how an elastic IP can be used. There are many other use cases, and it's an important feature of AWS. In this lecture, we will provide a hands-on guide to working with elastic IPs. The objective is to create an elastic IP and attach it to our existing instance. This way, we have a reserved IP that never changes even if the instance state is changed. Let's go ahead and get started. Back in the EC2 console, in order to create an elastic IP, we're going to scroll down on the left navigation menu and select Elastic IPs. Now in the Elastic IP console, click on Allocate Elastic IP Address. Now leave the default settings and click Allocate. You'll now see the elastic IP appear in the table. So all your elastic IP addresses will be visible in this table here. This particular IP address we just created doesn't have a name, so let's go ahead and just name it. I'll call it Elastic IP Demo. This is the IP address associated with this elastic IP, and we can see that the type is a public IP. So this is going to be accessible through standard web protocols. The next thing we need to do is attach this IP to our instance. So make sure there's a check mark next to the elastic IP here. Now click Actions. And you're going to select Associate Elastic IP Address. Now from the options list, select Instance as the resource type and select the instance from the input. So this is the instance we have here. Okay, that's the only one we have running, so just go ahead and select that. And at the bottom here, click Associate. Now we'll need to switch back to the Instances dashboard. And we're going to confirm that our elastic IP is now attached to our instance. So click on the instance itself to display the instance summary at the bottom here. Under the IPv4 address, you should now see the elastic IP address rather than the standard IP that was issued when the instance was deployed. And so this is the correct IP, and you can see the elastic IP name we'd given it right next to the IP. Under the heading Elastic IP Addresses, you'll also see the elastic IP address there because this IP address is now associated with this instance. Now we can plug this elastic IP into our browser to pull up our default HTML page that we'd created with the user data when we initially launched the instance. Okay, so if it doesn't load, the reason for that is because your browser by default is trying to access the HTTPS protocol where we want just HTTP. Okay, so make sure you change the prefix to HTTP and you'll see that the HTML page does appear. So our elastic IP is associated and it is in fact working. It's important to note that if you want to keep your elastic IP free of charge, you'll need to do the following. Make sure the elastic IP is associated with an instance or network interface. Make sure the instance associated with the elastic IP is running, and only attach one elastic IP to an instance. In the next lecture, we'll go over instance administration. In this lecture, we'll go over some basic administrative options that are available for your EC2 instances. Let's go ahead and get started. To access the administrative options, right-click on the instance row pertaining to the instance you want to administrate. So we only have one, so just right-click on the row. Now you'll see a menu appear with a number of options. For now, we'll go over some of the basic options that you'll be using quite frequently. The first item on the menu gives us the option to launch instances, which by now you're likely quite familiar with. In addition to launching instances, we can also stop an instance, reboot the instance, and terminate the instance. Let's take a look and see what happens when we stop our instance. Go ahead and click Stop Instance and confirm the request by clicking Stop again. right away you'll see the instance state change to stopping. Now this can take a couple of minutes. Stopping an instance is the equivalent of turning off a server. As long as your data is stored on a persistent volume, nothing will be lost by stopping it. When the instance is stopped, the instance state will also change to stopped. So as you can see, after I've refreshed the table, the instance state has changed to stopped. So the stop request has been completed. It's also important to note that since we're using an elastic IP, our IP will no longer change once the server is started again. If we hadn't attached an elastic IP, the IP would change each time the instance is stopped and started. When the server is stopped, it's inaccessible using the public IPv4 address, and we can confirm this by trying to load our default web page in our browser. So I'll just go ahead and copy the IP, type in the HTTP prefix, and paste. The reason you see this page right now is because it was loading from my computer's cache. So I just did a hard refresh, and now you can see that the page is not loading. The wheel just keeps spinning. Okay, there we go. So this site can't be reached any longer, and that is because our instance is off. Okay, now I'm going to go back here to our EC2 console, and let's go ahead and start the server again. So right-click on the instance, and click Start Instance. Okay, so I'll just refresh, and the instance state is pending, so the server has not started just yet. We'll just have to give it a couple of minutes for the server to boot back up. Okay, so the instance state is now running. I'm just going to load the instance summary so you can see that the IP address has not changed. The IP is still the elastic IP that we'd associated with this instance. Now, just as a reminder, you do not incur any charges for a stopped instance. You're only billed for the duration of time that a server is running during a given billing cycle. Now let's go back into our admin menu and see what other options are available. So I'll right-click again. So the next thing we have here is the ability to reboot the instance. This means AWS will stop and restart the instance automatically. Terminating an instance will completely destroy this EC2 instance and all data stored locally. Once an instance is terminated, the action is final and cannot be undone. Now we'll skip over some of the other items in this menu for now, since they'll be covered later in this course. For now, we're going to jump to the networking menu. So just hover your mouse over it and you'll see a sub-menu appears. So in this submenu, you have the option to disassociate the elastic IP address that we'd associated earlier. And once the elastic IP is disassociated from this instance, we have the option to attach it to another. So let's go ahead and see how that works. Just click Disassociate Elastic IP Address, and you'll get a confirmation page. Just click Disassociate, and you get a third confirmation, and it says to confirm disassociation, enter proceed. So just type in proceed and click disassociate again. Okay, so right away, you'll notice that our IPv4 address has now changed since our elastic IP is no longer associated with this instance. While the elastic IP remains unassociated, we do incur charges for the elastic IP. I have to be careful here not to leave the elastic IP in this current state for too long, because I don't want to be billed for it. If you don't plan on using the elastic IP again, then it's a good idea to release the IP. And we can do this by clicking on elastic IPs from the navigation menu here. Make sure that the IP is checked and click on Actions and click Release Elastic IP Address. Confirm it. And there we go. Once complete, the elastic IP is no longer visible in the table and you're no longer incurring charges for it. Now go back to the instances console, and in the next lecture, we'll talk about instance launch templates. In this lecture, we'll demonstrate how to launch an instance from a launch template. A launch template offers a more efficient way to launch one or multiple instances based on saved configuration settings from previous instances. For example, as you might recall, when we deployed our EC2 instance using an AMI, we had to specify the instance type, network settings, storage, security groups, and more. It would be tedious to have to configure these options each time we want to launch an instance with the same settings. This is where templates can help. By creating a template, we'd predefine all the EC2 properties within the template to be used in the future deployments of EC2 instances. Another benefit of using launch templates is the ability to create one or more numbered launch template versions. Each version can have unique launch parameters, which provides a great deal of flexibility. Let's go ahead and get started in creating our first launch template. As you'll see firsthand, creating launch templates is simple. To do so, expand the Instance Administration menu by right-clicking on your instance row. Scroll down to Images and Templates, and from the sub-menu, select Create Template from Instance. We're now taken to the configuration page where we can specify a number of options pertaining to this template. First, you'll notice this source instance defaults to the only instance we currently have running. If we had multiple instances, you would have a select menu of options. Next, we'll need to name our template. I'll go ahead and call it Template 1. Now we'll need to enter a version description. Let's call this My First Launch Template. This will make it easy to identify if we have a number of them. As we scroll down the page here, you'll notice a number of configuration options that by default are identical to what we had when we deployed our initial instance. This includes the AMI we used, the instance type, the key pair we created, the network settings, and if we scroll further down, the network interfaces. The resource tags for the instance are also stored here, and the storage volumes. Now expand the Advanced tab, and if you scroll all the way down, another thing you'll see here is the user data that we originally inputted when we created this instance is also here. Now if you include this user data as part of this template, that means that any instance that's created from this template will also include the user data. Let's assume that we want this template to maintain the same configuration as the instance we initially deployed. What we can do now is just leave all the settings as default and then press Create Launch Template. We now have a success message that the template has been successfully created. Go ahead and click View Launch Templates to return to the instance console. Now from the left menu, click Launch Templates. And this is the Launch Templates console where we can see the template we just created. This is the Launch Template ID. This is the name that we'd given it, the version, when it was created, and who created it. Now with the template selected, if you click the Actions menu, there's a number of administration actions we can perform on this template. For example, we can delete it, or we can modify it. We also have the ability to launch a new instance from this template, and that's available as the first option here. As you can see, launch templates simplify the process of deploying instances based on similar configurations. Let's head back to the Instances dashboard before our discussion on a related topic, which is instance images. In this lecture, we'll demonstrate how to create an Amazon machine image from an existing instance. An AMI is similar to a launch template, but with much more information contained within it. Since we've explored the theory behind AMIs earlier in this course, this lecture will be more of a hands-on guide to working with AMIs. As per the AWS documentation, when we create an AMI from an existing EC2 instance, it will contain the following information. All of the information included in a launch template, software-related components such as operating system, application server, and any applications, one or more Amazon Elastic Block Store snapshots, launch permissions that control which AWS accounts can use the AMI to launch instances, a block device mapping that specifies the volumes to attach to the instance when it's launched. So with that said, let's go ahead and get started. Back on our instances console, the first thing we're going to do to create an AMI is right-click on our instance, and from the Image and Templates menu, select Create Image. We're now presented with options for configuring the image. First, we need to give the image a name. I'll go ahead and call it First EC2 Image. We also have the option to give the image a description, expand the size of the EBS volume included in the image, add an additional volume to the image, and create tags for the image. Since we just want to use the default options, go ahead and click Create Image at the bottom here. We can now see that the image was successfully created from our instance. Let's navigate to the AMI's dashboard to confirm. From the left navigation menu, click AMIs. The AMI dashboard contains a list of all the images you've created. They will be listed sequentially in the AMI table. As you can see, the status of this AMI we just created is pending. This means it's not ready to be used just yet. Depending on the size of the instance and EBS volumes associated with this AMI, this could take several minutes to complete. I'll go ahead and refresh just to make sure that there's no status updates. It looks like it's still going to take a bit more time. So after about 5 minutes, the status has now changed to available, meaning the AMI is ready to be used. We can administer this AMI by making sure it's checked and clicking on the Actions menu. From this menu, we can launch an instance from the AMI, copy the AMI, and modify some details pertaining to the AMI. There's also some other options as well, but we won't go over those for now. What we do want to do right now is deploy a new instance from this AMI, because this is something you might be doing quite frequently. So go ahead and click the Launch button. Since this instance will be launched from our AMI, we don't need to configure any of the settings shown here. All we need to do is scroll to the bottom and click Review and Launch. You can go ahead and confirm the deployment settings and click Launch again at the bottom. For the key pair, select one of the existing key pairs we already have in our account. So from this menu, choose an existing key pair, and we only created one key pair previously. It was called Demo Instance. So use that key pair. You should already have it saved on your computer. Accept this acknowledgement here and click Launch Instances. Our new instance is now being set up. So go ahead and click View Instances. And when the status of the instance has changed from pending to running, we'll know that the instance is ready. So there it goes. It only took a few seconds this time, but sometimes it could take up to a minute or so. So this instance is now running. Now, one thing I want to point out is when you click on this instance and copy its IPv4 address, if I plug this into my browser with using the HTTP prefix, you'll notice it doesn't load the page that was configured in our user data. And the reason for this is that this instance is attached to the wrong security group. Okay, this instance is attached to a security group that doesn't have the right ports open. Port 80 is not opened on this instance. So we need to change the security group to the same one used by our first instance. And we know that the first instance does work because the IP actually pulls up our HTML page that was configured in the user data. Okay, so I'm going to go back to the EC2 console, and I'm going to right click on this second instance. We're going to expand the security menu and select Change Security Groups. We're now presented with some information regarding the security groups associated with this instance. You'll notice in the bottom row, we have the security group Launch Wizard 2 listed as the security group that this instance belongs to. This is not the same security group associated with our first instance. We can confirm this by going back to Instances. I'll just click Instances here. Now I'm going to click the first instance to see its properties. And under the Security tab, you'll notice that this instance belongs to security group called Launch Wizard 1. So this is the same security group we want to attach to our second instance. Okay, so once again, return to the security groups page, right click on the second instance, click security, and change security groups. So we're going to remove the Launch Wizard 2 security group, and we're going to add Launch Wizard 1. Now click add, make sure to click add security group. And once you see the new security group, or the correct security group, Launch Wizard 1, appear in this table here, you can go ahead and click Save. Now I'm just going to go ahead and rename this to Demo Instance 2. So that way you can clearly see which instance we're working with. Okay, now if we go back to the Security tab for Demo Instance 2, we can see here that this instance is now associated with the right security group, Launch Wizard 1. The instance also now has the right ports open to accept incoming HTTP requests. Let's go ahead and switch back to the Details tab and copy the IP once again. And we're going to plug it in with the HTTP prefix. And there it is. The web page is now working. This is the HTML file we'd configured in our user data. It was copied over from our Amazon machine image, and that Amazon machine image was built from our first instance. So we have two instances that are exact replicas of one another. Okay, now when we create the Amazon machine image, it also copies our EBS volumes. So the EBS volumes from our first instance are duplicated to the second instance, and we can confirm this by clicking Volumes under Elastic Block Store, and you'll see two volumes here. We have two identical EBS volumes, one attached to each instance. Okay, let's go back to the Instances console, and what we want to do now is delete the second instance, or terminate the second instance, because we don't want to rack up hours and incur charges. The free tier includes 750 hours of usage time, and if you have two instances running, then that 750 hours is now divided by two instances. So to terminate the instance, right click on the instance, make sure you are terminating Demo Instance 2, and click Terminate Instance. And confirm that you want to terminate. Now, if you refresh the table, you'll notice that there's a shutdown process in effect here. So this instance is now shutting down, and AWS will take care of the entire process. It'll shut down the instance, and once the instance is shut down, you'll also notice that the instance state changes to terminated. Now, this could take a couple of minutes. Okay, so there it is. The instance state has now changed to terminated. Now you might wonder why this instance is still in our table if it's terminated. What's going to happen is after an hour or so, this entire row will purge from this table automatically. You don't have to do anything. But it does take a little bit of time for that to happen. Now we'll want to confirm that the EBS volume attached to this demo instance too has also been deleted. So go back to volumes. And we now only have one EBS volume, which is exactly what we want. Okay, so after you've made it this far and confirmed that your volume has been deleted, let's go back to the instances console. Over the last couple of modules, we've made reference to IAM roles, but haven't yet explored this concept in detail. However, it's an important one to know, so this lecture will provide a detailed overview of what they are and different use cases. Up to this point, we've worked with IAM identities such as IAM users and groups, and by now you likely have a good understanding of how identities work. If you recall, when we created an IAM user, we were able to attach a policy to the user in order to provide access permissions to different services and resources in our AWS account. Similar to IAM users, an IAM role is also an IAM identity that is linked to a policy which governs access permissions. However, a role is intended to be used by any person or application that needs the permissions and policies associated with it. Also, unlike an IAM user, a role does not have standard long-term credentials such as a password or access key. When a role is assumed by an application or a user, temporary credentials are created for the role session. So let's go over a few examples of when roles might be used. One example is when we need to grant permissions to users, applications, or services that don't typically have access to your AWS resources. Another example is granting users in one AWS account access to resources in another AWS account. Thirdly, granting access to an application running on an EC2 instance that needs to perform actions on AWS resources. Allowing mobile apps to use AWS resources without having to embed AWS keys within the app. Granting access to an AWS account to third parties for the purpose of auditing resources deployed in the account. As defined by the AWS documentation, roles can be used by the following: an IAM user in the same AWS account as the role, an IAM user in a different AWS account than the role, a web service offered by AWS such as Amazon Elastic Compute Cloud or Amazon EC2 for short, an external user authenticated by an external identity provider service that is compatible with SAML 2.0 or OpenID Connect, or a custom-built identity broker. Now that you understand a little bit about roles, in the next lecture, we'll go over an example to really give you a good idea of how they work. In this lesson, we will provide a practical guide to using IAM roles through an example use case. One of the most common use cases for IAM roles is to grant an Amazon EC2 instance permission to execute actions on S3 storage. In other words, we're giving our virtual server the permission to read and write objects on an S3 bucket. By default, when you create an EC2 instance using any IAM identity, it does not have permission to execute any action on the S3 service. For this reason, it's a perfect way to learn how roles work by going through a hands-on exercise which will demonstrate how to configure a role for this exact purpose. In this lesson, we'll demonstrate how to create a role which would give an EC2 instance permission to access all resources on the S3 service. To get started with this exercise, we'll have to navigate our way back to the IAM dashboard. So just click Dashboard here. Now from the left navigation menu, click Roles. The first thing you'll see at the top here is a message which provides some information on how roles can be used. And directly below that, we have a Create Role button. So go ahead and click that. The first thing we're asked to specify is the trusted entity. Trusted entities refer to a set of entities that can assume the role we're creating. Once the role is attached to the trusted entity, the entity will have access permissions on the resources specified in the policies attached to the role. There are 4 types of trusted entities, which we can see at the top here. This includes an AWS service, another AWS account, a web identity, or SAML 2.0 federation. For the purpose of this exercise, make sure AWS service is selected, since we want to give the EC2 service permission to access S3. Now we need to select a use case. So under the heading Common Use Cases, select EC2, since that's the service we're going to be working with. Now click Next. We now have to attach the AWS managed policy that grants access to all resources on the S3 service. So we want to grant our EC2 instance access to all resources on the S3 service. So type in S3 here and select Amazon S3 full access. Place a check mark here. Now go ahead and click Next. We don't need to add any tags, so click Next again. We'll need to give this role a name. A name is required, so just type in EC2 S3 access. You can put in a role description if you like, but you don't have to. All that's required is a name, and everything else is fine, so go ahead and click Create Role. We can now see the role we created in the table. Click the role to view the role summary. The role summary provides some valuable information. So under the role description label, we can see the purpose of this role. It allows EC2 instances to call AWS services on your behalf. We can also see the last activity on this role within the tracking period, which is normally 400 days. Next, we can see the maximum session duration for this role, which is set to 1. So 1 is the default. 1 hour is the default. We can change this to any value between 1 and 12 hours. So if you click Edit, you'll notice you have different options to select from, but leave it as 1 hour for now and click Cancel. We'll demonstrate how session duration comes into play when we work with EC2 instances in the AWS Compute section of this course. Now below that, we have a number of tabs here. So we can see the permissions attached to this role, trusted entities assigned to this role. There's an access advisor, which shows the services this role can access and when they were last accessed within the tracking period. We also have the option to revoke all active sessions. Now at the top right corner, we can delete this role if it's no longer required. Now with our new role created, we have the option of attaching this role to any EC2 instance we deploy. Since we haven't yet deployed any instances, we'll demonstrate how this part works in a future section of this course. For now, it's just important to understand what a role is and the different ways a role can be used. Here is a visual illustration of what we did when we created the last role. So as this diagram illustrates, we first created our role, attach the EC2 instance to the role. Now any app that runs from the EC2 instance will have access to the S3 storage bucket. In this lecture, we will provide a hands-on guide to creating IAM roles specifically for Amazon EC2 instances. Remember, IAM roles can be used to grant permissions to applications running on our EC2 instances to access specified services and resources on AWS. In the previous section, we had already created a role that specifically allows the EC2 service in our AWS account full access to perform any administrative task on the S3 service. As a quick refresher, let's go back to our IAM roles console and take a look at the IAM role we had set up. The first thing we'll need to do here is navigate our way back to the IAM roles console. To do that, type in IAM in the search bar and select roles. In the roles table, you should see 3 roles. The third role in the list is the one we had created to grant permissions to S3 from EC2. We had named the role EC2 S3 Access. As you can see, the trusted entity for this role is the EC2 service. Go ahead and click on the role, and that's going to open up the role summary. We can see that the policy attached to this role is Amazon S3 Full Access. Perfect. Since we already have the role set up, all that remains is attaching our instance to the IAM role. This way, our instance will have the same access rights under the policy attached to this role, which in this case is Amazon S3 Full Access. So let's head back over to the Instances console. Now right-click on the instance, and from the admin panel that opens up, you're going to select Security, and from the sub-menu, select IAM, Modify IAM Role. Now from the Select menu, you'll notice that the EC2 S3 Access role is available. Go ahead and select that role and click Save. If your role was successfully attached, you will see a success message at the top of the instance console. Now, if you go ahead and click the instance row to open up the instance summary, you'll also notice that the role is listed under IAM role. So there it is, EC2 S3 Access. Now that the IAM role is attached to the instance, any applications running on the instance will have full access to perform any actions on the S3 service. This includes reading and writing to S3 storage buckets, which is a very common use case. In this lecture, we will expand on our discussion regarding security groups. Let's go ahead and start off by defining some of the key characteristics of security groups. As defined by AWS, a security group acts as a virtual firewall for your instance to control inbound and outbound traffic. When an instance is launched within a VPC, it can be assigned to up to 5 security groups. If an instance is launched using the Amazon EC2 API or a command line tool and a security group is not specified, it will automatically be assigned to the default security group for the VPC. Whenever an instance is launched using the AWS console, you're presented with the option to create a new security group for the instance. A security group is composed of rules. These rules define the parameters of the firewall which guards your instances. The rules are enforced by filtering traffic based on protocols and port numbers. Rules for a security group can be added and removed, also referred to as authorizing or revoking inbound or outbound access. The security group rules are divided into inbound and outbound rules. you can specify separate rules for both inbound and outbound traffic. AWS permits specifying allow rules, but does not allow deny rules. When a security group is created, it has no inbound rules by default. This means all inbound traffic originating from another host will be denied until inbound rules are configured. By default, a security group will have a rule that allows all outbound traffic. Outbound traffic rules can be configured to restrict outbound traffic. A security group with no outbound traffic rules will deny all outbound traffic requests made by an instance. So now that you understand more about the foundations of security groups, in the next lecture, we'll offer a practical hands-on guide to help you solidify some of the concepts we've just explored. In this lecture, we'll provide a hands-on guide to working with security groups. To get started, we'll need to access the Security Groups console. To do so, click Security Groups from the left navigation menu. The Security Groups table will list each security group pertaining to this AWS region. This region currently has 3 security groups, which can be identified by the security group ID and security group name. The security group can also be given a label by entering a name in the name column. The security groups active in this AWS region include the default security group, followed by Launch Wizard 1 and Launch Wizard 2. We created Launch Wizard 1 when we deployed our first instance. Launch Wizard 2 was created when our second instance was deployed from our AMI. The default security group is associated with our VPC within the AWS Cloud Service. Let's click on the default security group to view its current configuration. Here we can see this security group has 1 inbound rule and 1 outbound rule. The default rule allows all inbound and outbound traffic that originates from an instance within our VPC. The default security group cannot be deleted. Now let's head back to security groups. We'll now take a look at Launch Wizard 1, which is attached to our currently operational EC2 instance. Here, we can see the security group currently has 3 inbound rules and 1 outbound rule. The inbound rules allow HTTP traffic on port 80 using the TCP protocol. The values you see listed under source indicate that there are no restrictions on the IP for inbound traffic. This means traffic can originate from any IPv4 or IPv6 address. There's also a rule that allows SSH traffic over port 22 from any source IP. Now, over to the outbound rules. Here we can see that there is 1 rule which allows all outbound traffic to any destination IP using any port and protocol. Now switch back to inbound rules. Let's say we wanted to edit or add an additional inbound rule. To do so, go ahead and click Edit Inbound Rules. We can now make changes to our existing rules or delete them altogether. We can also add a new rule by clicking the Add Rule button. Let's go ahead and add a new rule which would allow incoming HTTPS traffic from any source IP over port 443. This is a typical rule for instances running websites since you would want to allow both HTTP and HTTPS traffic. So go ahead and click Add Rule. For the rule type, you're going to select HTTPS, and if you can't find it quickly in the list, just type in HTTPS to filter. So there it is, I'm going to click on it. The protocol and port will automatically be added. All we need to do is specify the permissible source traffic that can access our instance over the designated port. To allow traffic originating from any source IP, select the following. With your new rule added, go ahead and click Save Rules to save the new configuration. We can now see our new rule has been added to the inbound rules list for this security group. Let's head back to the main security groups console. To create a new security group altogether, we can click Create Security Group. Under Basic Details, we need to enter a security group name. I'll go ahead and enter Test Group. We also need to give this security group a description. I'll enter My Test Group. Next, we need to specify the VPC for this security group. This is automatically done for us because we only have one VPC, which is the default VPC. We now have the option to add both inbound rules and outbound rules. For inbound rules, let's go ahead and add SSH access because this is something you definitely want to have. So after I've clicked the Add Rule button, I'm going to look up SSH. The protocol and port are automatically assigned. And this time, let's specify that we only want to allow SSH traffic from our IP. Again, this is a common use case. So from source, I'm going to select my IP. AWS will automatically check your IP and add it to the source list. We can leave outbound rules as default. So all we need to do is scroll down and click Create Security Group to finish. We can see that our new security group has been successfully created. So return to the security groups console to see your updated list. So here it is, Test Group. That's the new one we just created. For the purpose of this exercise, let's go ahead and now delete a couple of security groups we don't need. We no longer need the Launch Wizard 2 security group since we deleted the instance that was associated with it. We did this earlier in the course. We can also delete the security group we just created. We'll delete the Test Group and Launch Wizard 2. So to do this, place a check mark in the row for each security group you want to delete. Now from the Actions menu, scroll down and click on Delete Security Groups. To confirm deletion, enter Delete and press Delete. So hopefully you were able to follow along. You now have a good understanding of how to work with security groups within the AWS console. Let's go ahead and navigate back to our instances. In this lecture, we will provide an overview of Secure Socket Shell, SSH. SSH offers a secure way to administer an EC2 instance through command lines over an open network such as the Internet. As the administrator of a virtual server running on AWS, there will be many instances where you need to remotely administer the server using command lines. SSH connections between two computers are facilitated through SSH clients. The SSH client you use to connect to your EC2 instance will depend on the operating system that is installed on your local computer. For example, Mac users can SSH to an instance using Terminal. Terminal is included in the Mac OS by default. Linux users can SSH to an instance using Linux Terminal. Windows users will need to install a third-party program called PuTTY. PuTTY is a free and open source terminal emulator which supports SSH connections. If you don't have access to an SSH client on your local machine for any reason, AWS also offers an online web-based SSH client known as EC2 Instance Connect. However, this client has the following limitations. It can only be used to administer instances using the Amazon Linux 2 operating system. Web-based SSH clients often have some latency and are slower than desktop clients. Web browsers are prone to crashing and freezing, which makes reconnection a bit inconvenient. We'll go over instructions on how to install and operate each client later in this section of the course. SSH connections offer a lot of features. For example, they provide a secure way to access system resources between a host and a client. They allow the remote execution of commands to a virtual server. They allow the administration of software patches, updates, and other management tasks on a remote system. They also facilitate secure file transfer between a client and a host. In the next lecture of this course, we'll provide a practical guide to working with SSH. In this lecture, we will provide a hands-on guide to installing and connecting to our Amazon EC2 instance using PuTTY for Windows. In preparation for this lecture, you will need to locate the demoinstance.pem key pair you downloaded to your computer earlier in this course. With that complete, let's go ahead and get started. The first step here is to create a folder on your desktop called PuTTY. This folder will store the setup files for PuTTY. Next, you're going to head over to putty.org and click this link here to download PuTTY. From the download page, you're going to right-click on the 32-bit download link. Click on Save Link As. And you're going to save it in the PuTTY folder we just created. Once you've downloaded PuTTY, scroll down and we're going to download PuTTyGen. And I'll explain what that is in just a second. So we're going to download puttygen.exe 32-bit. Right-click on the download link, save link as, and save it in the same folder as the putty.exe file. So PuTTY is going to be our SSH client, but PuTTygen is a key generator tool. We need this because the PEM key files that are provided to us by AWS are not compatible with PuTTY. They first need to be converted to PPK files. And PuTTygen makes this conversion from PEM to PPK possible. PPK files are compatible with PuTTY. So I'm back on my desktop, and I'm going to open up the folder which contains the two executable files I just downloaded. I'm also going to open up the folder where I've been storing all the keys we've been generating throughout this course. So you can go ahead and do the same. Hopefully you've been storing all your keys in one folder. Your demoinstance.pem file should be in that folder. So the first step here is to convert our PEM file to PPK so it's compatible with PuTTY. So go ahead and launch PuTTygen. I just double-clicked on PuTTygen to open it. Now we're going to go to File, Load Private Key. And you'll notice we don't see the PEM file visible here. That's because on the right, at the bottom right corner here, we've got to change from PPK to all files. Right now it's only looking for PPK files and we don't have any. Select demoinstance.pem, click Open. And when this notice pops up, just go ahead and click OK. Make sure for parameters you have RSA set, and for number of bits in a generated key, set it to 2048. Now go ahead and click Save Private Key. Are you sure you want to save this key without a passphrase to protect it? Just click Yes. Just save it as demo instance and it'll automatically add the PPK extension, which is what we need. Okay, so now I have my PPK file created. demoinstance.ppk. It's in the same folder as the .pem file. We can now close PuTTY key generator. We no longer need it, so I'll close that down. Now open putty.exe. With PuTTY open, there are a few parameters we need to complete in order to connect to our EC2 instance. So the first thing it's asking for is our host name. Anytime you deploy an EC2 instance, it'll come with a public IPv4 DNS address, and this address is needed in order to remotely connect to our EC2 instance through PuTTY. So to get this address, I'm going to flip back over to our instances console, and make sure you click on the demo instance row, because you need to be able to see the summary below. We'll need some information from here. Under public IPv4 DNS, click this button here, this little icon. That's going to copy your address. Okay, now I'm going to head back over to PuTTY. Now we're going to paste that address in the host name. In addition to the host name, we also need to specify the user we are connecting with. So we've specified the host, but we also need to add the user. The default username to connect to an EC2 instance is EC2-user. This username must be used when connecting. To enter the username, position your cursor at the very beginning of your IPv4 DNS address. So make sure your cursor is right at the beginning, and type in EC2-user and then the @ In addition to that, make sure the port number is 22 and the connection type is SSH. Now we have the basic connection settings configured. All that remains is adding the private PPK key we generated using PuTTYGen. This key is needed to authenticate into our instance. This is where the handshake takes place between our private key stored on our local machine and the public key stored on AWS. So that's what this PPK file is going to be used for. To load the private key, expand the SSH submenu from the category menu. And under SSH, you're going to click Auth. Beside the private key file input, click Browse. And you're going to go back to the AWS keys folder, or whichever folder you have your keys in. And I'm going to load demoinstance.ppk and click Open. Okay, so we're all set. Since we might use this configuration in the future, let's go ahead and save it so we don't have to repeat these steps over and over again every time we want to connect to our instance. So just scroll up in this menu here and select Session. And in the saved sessions input, we'll give this session a name and save it. So just type in first EC2 and press Save. And you'll see it pop up in this menu here. So now that this configuration is saved, you no longer have to input all these parameters each time you want to connect. You can simply load it by double-clicking on the save session. Okay, I'll just do that one more time because it happened a little bit fast. I'm going to exit this. I'm going to go back into PuTTY. And so here's my save session, first EC2. Okay, I'm going to click Load, and you'll see that the parameters pop back in, and the authorization key or the private key is also saved in our configuration. Okay, so perfect. Now I can go ahead and click Open to connect to the instance. If this is your first time connecting, you'll probably see a dialog box that looks like this. If you do see that, just click yes in order to proceed with the connection. If the connection was successful, you'll see the Amazon Linux 2 AMI logo, and below that you'll see your username, EC2-user at your IPv4 address. This is mine. You'll have a different one there. So that's great. We're now connected to the server and we can execute commands to the server. I'll go ahead and show you an example of executing a couple of commands. So I'm going to type in sudo yum update. And this command is used to update the Linux packages and dependencies to their most recent versions. This is a very commonly used command. Don't worry if you know nothing about commands. We're just showing you how to connect to your server. Actually administrating a server through command console, that's a whole different course on its own. So right now, up to this point, you just need to know how to connect to your server. And just as a sample, I'm just going to show you a couple of basic commands to update the repositories on the server. So don't worry if you don't know what these commands mean. It's just a general example to show you how command execution works. So let's go ahead and press enter once I type that in. Now there's no packages here to be updated. That's what this message means. That means all of the packages on our server are up to date. Now if there were packages that had been updated, we would then need to install these updated packages to replace our outdated packages. And for that, I would type in sudo yum upgrade. Okay, and no packages have been marked for update. So as you can see, nothing was upgraded because there is nothing that has been updated from our last command. But if there was, you would see a number of items start appearing here to show the process of the upgrade. Okay, so these are the two most basic commands that you would execute on a virtual server just to keep your Linux servers up to date. So that's all there is to it. In this lecture, you successfully connected to your instance using PuTTY SSH client, and you also executed your first set of commands. So now you can go ahead and close PuTTY since we won't be using it for a while. Okay, when you press the exit, you'll be asked if you want to close the session. Just go ahead and click OK. Now don't worry if you're on a Mac. We're going to show you in the next lecture how to connect to your instance from a Mac computer. And if you don't have access to a client for any reason, we'll also be showing you how to use EC2 Instance Connect, which is a web-based client offered by AWS. And that way you don't have to use any desktop clients to connect. But we'll get more into that in the lectures to follow. In this lecture, we'll demonstrate how to SSH to an EC2 instance using the web-based EC2 Instance Connect client. Keep in mind that this client only works for instances configured with Amazon Linux 2 operating system. Since that's what we're currently using, the client will work for our purposes. Let's go ahead and get started. From your instance's console, you're going to right-click on the instance row and select Connect. Now make sure that once you do that, you have the EC2 Instance Connect tab selected. Also make sure that the username is set to EC2-user. Once you've confirmed those two things, go ahead and click Connect. The SSH client will immediately launch and you should be connected to your EC2 instance through your web browser. Similar to when we connected with PuTTY and Terminal, you'll see the Amazon Linux 2 AMI at the top, your username, and followed by the IPv4 DNS address. So that indicates a successful connection, and we're now ready to start executing commands. So we'll go ahead and execute our update and upgrade commands. Okay, and everything is working as it should. So as you can see, the web-based client is a quick and easy way to execute commands to your server. Hopefully in the future, AWS does offer support for more than just the Amazon Linux 2 AMI. But once you are done with that, you can go ahead and close that window and return back to the instances console.